Hello, I'm David Kerr, Professor of Cancer Medicine at the University of Oxford, and I'd like to turn your attention to a fantastic review article that I enjoyed reading recently in Annals of Oncology. The title is Somatic Variations in Normal Tissues, Friend or Foe of Cancer Early Detection, and it's from an excellent group from the Francis Crick Institute in London. With the advent of much more sophisticated, much more sensitive DNA sequencing, analytical, and bioinformatic techniques, has become apparent that in normal tissues, we can find somatic mutations in many of the so-called driver genes, which are involved in the process of carcinogenesis. So as we get older, we accumulate more of these mutations in normal tissues. So we find that patchwork quilt. It depends on the geography of the tissue, the type of tissue, how old we are, and so on. But this is a really thoughtful, interesting article. That we assume, don't we, that normal tissue is normal, genetically and phenotypically, and cancer is a collection of mutations, which eventually there's a tipping of balance, and that cell which has accumulated most mutations, most driver mutations, is the one which outgrows and behaves like a cancer cell, hyperproliferative, invasive, with metastatic potential. What they've shown us, or what we've learned with these new DNA sequencing techniques, is that normal tissues can harbor quite a patchwork of these somatic mutations. There's some work in lung cancer in which 49% of lung cancer patients have mutations in P53, but so did 11% of normal healthy controls. And so it tells us a lot about those who are interested in the biological evolution of tumors. Why do some tumor cells succeed? Their fitness to succeed. Why are they different than others? We know that in terms of somatic mutational variation in normal tissues, some of these mutated clones can come and go, they can disappear, they can be outcompeted. So there's something fascinating about the ability of some driver mutations to outcompete others. And again, this is tissue specific in terms of their meta-analysis. But think about these new tests that are coming along, like GRAIL, in which we're being persuaded that looking at in normal individuals with low circulating, low copy-numbered DNA, that if we can detect mutations in P53 or RAS or RAF or whichever we think the important drivers might be, that these might be reflecting, especially in older people, non-malignant changes in normal tissue. So the possibility of false positives is a very significant reality, something that will be tested in some of the enormous prospective studies that are going on. But I find this a really thoughtful review, a challenging piece of biology, and in some ways not surprising, of course, but only now are we able to detect these, given they're ultra-sensitive, that given the depth of DNA sequencing that we can now undertake. And of course, there will be field change in colonic tissues, exposure to the various dietary carcinogens and the various insults of normal life that we go through. Of course, there will be field change, but this complicates the how we aim to look for early detection of cancer using genomic tests. Now, except that if rather than just looking for circulating fragments of DNA, you may look for patterns of methylation and so on. This might help to distinguish genuinely precancerous tissue than just quasi-passenger somatic mutations in normal tissue in healthy people. But it's going to be a challenge for those who believe that we can use circulating DNA as as a holy grail, as the answer to us being able to detect tumour at an incredibly early stage. Have a look at it. It's beautifully written. There's a thoughtful piece about the biological evolution of cancer and fitness to proceed, but also with that potentially clinical element to it as to what this might mean for large-scale genetic testing as a means of detecting cancer at an earlier stage, something which is terribly, terribly important. I'd be very interested in what your thoughts are. Please post them, please let me know. And for the time being, Medscapers, ahoy.